Hello, my name is Froilan Morales, and I'm from the University of Texas in Brownsville. I'm working with Dr. Lee, and I'm going to show an AOI inspection on PCB boards. Okay, so the first thing we have to do is acquire the images we're going to be analyzing. We'll browse through this folder and we'll go to the correct images. It's a prepared image folder I have, which they have all correct PCB chips. So here we click this icon and it will cycle through all the images in the folder, and we could check the images here. They're identical images. The only thing they do is they jump around to check the grid system we're gonna do in a moment. Okay, so the very first thing we have to do is go and get a match pattern, something in a board that's always gonna be there, so we could recognize each board and get their correct angle each time. So we'll select this part here. Okay, the program automatically detects this part and it will do it for each board. Doesn't matter if the board tilts a little bit or moves. As you can see here, it'll detect it wherever it is. So now that we have that, we'll make a coordinate system that works with that part, so that all the tools after that can align, even though the PCB switches. So we'll select the horizontal, vertical, and angular motion. This makes the image adjust, and you can see here that this arrow here is like a coordinate system that aligns everything with it. And we could switch to the pictures and you see the coordinate system moving also with it. Okay, so after we have all this set, we can now start actually detecting the defects on the PCB. And we do this with a detect setup, which is really easy. You have to make a new template, which this template works as a golden model. This golden model is going to be checked with every image you put, and it'll detect to see if there's any defects on your current image. So we're going to make a new template, and here you put your area of interest, which in our case is the whole PCB board. So we're going to highlight it all here. Adjust it a little bit there. So here you have a lot of parameters. You can adjust the edge threshold or the edge thickness. In our case, we're going to do a very fast demonstration here, so you could know we could actually edit this, make it a perfect golden model. But since we're doing a short presentation, we're just going to leave it as it is. But in here, you could actually adjust it, adjust your pen width and erase marks you don't want, or add marks that you want in a certain place. But we're just going to leave it like this for simplicity. So after this, we have to name our golden image, which I'm gonna name golden image, and save it on the desktop so we can find it easy. Okay, so here you can see our golden image is here. Our alignment is set with our previous coordinate system, and since they're all identical images, they're just copies of each other, I'm going to put the percent of defect 0 since they're identical images. So here you can see this is the area that is checking it with, and it aligns it. Even though it moves, it aligns it with a PCB. So all of these, as you can see in this area, it passes all of the tests I put so far, even the defect test, since they're just copies of each other. So to check to see if this defect filter is working, I'm going to add some defective pictures, which I've edited myself, and see how the filter works. So here I'm going to go to the first imaging and add a folder I have pre-made with defective pictures. You just have to pick one, and the program automatically cycles through the whole images. So you click OK here, and you check the first one. Here, this is a correct image, so it passes. You could check here. It passes, and this one fails. The reason it fails, it gives you a light mark where it fails. You can see this red area here. One of these solder joints is covered up. And even though it's hard to see, like for a human, the computer detects it right away. It also tells you the parameter you put. It says that the percent of defect is too high. Since I put 0%, any kind of mistake, any kind of difference, it'll detect it right away. On this next example, you can see here all of this red area. There's supposed to be a circuit line here running through one of these solder joints, but I've edited and deleted it, and it detects as a failed PCB board. On this one, you can clearly see here that there's an extra PCB circuit line here, and it highlights it in red, and it clearly says does not pass. And once again, this image fails because two circuit lines are connected by this, which is a common error.
Can you highlight it where it is? Here, right?
It's here.
But you can display it, right?
Yeah, you could. It's very hard, like for a human to see, but you could zoom in. You could see that it's highlighted. It's highlighted in red, and it's there. So even a very minor change, the computer will be able to detect it. And once again, this image passes. And you could do this at a very high speed, and it does it really fast. Another thing you could do with this program is the OCR inspection, which detects characters on the chip to make sure this specific chip is supposed to be here. So this program also does this, which is really useful. You would highlight the area you want to check.
OCR symbols, right?
Yes, OCR symbols. And here you have to train the image to make it work like however you want. I'm sorry.
Do we need to tell the system what those characters are?
Yes, the system specifically tells you right here that it needs the correct string, the correct letters, and you just need to train it once and it'll detect it for all the images. So right here we could see it's IO VC-12VI. So you train the image and it detects it here right away. If I was to put a wrong string, it would say that the characters are not identical. So you need to save this file, and I'll save it as file 1. So there you can delete this, and you see that it recognizes the symbols on this specific chip. So this could be useful, for example, so not mixing up chips and not putting chips that are not supposed to be on this specific board.
Okay.
And that's basically it.
Can you go back to the second to last test image that still has two solder joints missing?
Second to the last image. Let's see.
Where it has two solder joints missing? Yeah, this one.
This one?
Did this testing find out those defects?
Wait, let me take out this. Oh, sorry. Hey, let me zoom in.
There's two solder joints missing, right?
Yes.
Can you find out?
Yeah, it already found. Well, it's because I deleted the checking accidentally. But
You got testing again, right?
yeah, hold on. Is the cord? This. I need to delete this. After this, make it again. One, two, one. Okay. There you go. I missed it. It's here. It's missing these two solder joints right here.
Okay. So it highlighted here, right?
Yes, and here, because it's also missing this
Missing
line.
a line.
Yep.
Okay. That's good. I think it's good so far. So I'm glad Freud made good progress. Okay, that's all. Thank you.
Okay.